we're Team 2048, the mini bots of Great Mills High School, and we will be discussing our design and plan for sorting fuel pumps in Area 4 and a design evaluation for our claw for precise transportation of objects such as palms, small service stations, and the equipment. Our goal was to design a part that will incorporate code to have the crate sort fuel palms into Area 4 and to design a claw that consistently pick up small objects on the table such as palms, and while doing so, abiding the material constraints and possessing persistent durability. The crate bot consisted of mostly Lego parts, most notably pins with friction and lever arms which made up the plow. The claw partly consisted of two servos mounted with servo brackets alongside more pins, lever arms, gears, and axle joiners. Due to the nature of the shape of the crate, there is no viable method of moving or sorting objects. This is where the plow comes into play, large enough to both move surface stations and palms, yet small enough to fit inside the large rubber bay. The plow utilizes multiple lift arms connected by axle joiners on either side. The plow is connected to the crate for two 3x3 axle joiners that are attached to Lego lever arms that are bolted onto the metal chassis of the crate. This video demonstrates the sorting capabilities of the crate bot when using the plow. The crate drove forward, turned of which converged the palms together inside the plow, and then reversed, resulting in the palms sorted within the area. We tested our design a cumulative 10 times, displaying a 100% success rate. Our claw consisted of a dual closing overlap design, of which would essentially pinch whatever object that was inside the claw when being closed. Additionally, bionicle teeth attached to the claw served the purpose of both driving into the object that was being picked up and directing them into the path of the closing claw. Here is a visual representation of our dual overlap design. The claw demonstrated satisfactory success across the board, picking up 3 palms 9 times out of the 10 testing trials, displaying a total success rate of 90%. Looking into the future, we would like to move the plow to the aft of the crate to resume functionality of the frontal bumper sensor, which may possibly enable perpendicular alignment to the game board. Additionally, reducing the size of the plow would require much more precision within the crate code, but would decrease the chance of collateral damage and may save parts for other components if needed. Lastly, the claw is mounted far from the plane of the ground, which when the claw is lowered, results in it being in an angle, not parallel to the ground. This inhibits the ability of it to pick up palms, and we would like to improve upon this in the near future.